In the cold silence of space, one question continues to echo louder than ever. When will humanity return to the moon, and stay there? After decades of dreaming and countless attempts, that vision is finally crystallizing. But not with outdated technology or flags and footprints. This time we're bringing steel giants, robotic constructors, and an unshakable ambition to build something permanent. At the heart of this vision is SpaceX's Starship, the most powerful spacecraft ever developed, not just a vehicle for exploration but the cornerstone of humanity's next great leap. The mission, to construct a permanent base on the moon, and the clock has already started ticking. To understand where we're going, we have to first understand what's being attempted. The lunar base is more than a destination, it's a declaration. SpaceX envisions a research outpost, a launch pad for deeper space missions, and a testing ground for the technologies that will one day take us to Mars. This base won't just host astronauts temporarily, it's being designed for permanence. A place where people can live, work, and innovate, on another world. The goal isn't just exploration, it's habitation. And to reach that goal, there's a timeline that will push the boundaries of engineering, human endurance, and international collaboration. Enter Starship. With its sleek stainless steel design and towering height, Starship looks like something from a sci-fi novel, but its capabilities are rooted firmly in cutting-edge science. It's fully reusable, incredibly powerful, and capable of carrying more than 100 metric tons into space. That means it can deliver not just people but entire buildings, modules, life support systems, habitats, rovers, and tools, directly to the lunar surface. This vehicle is more than transportation. It's a construction worker, a cargo freighter, and a lifeline. The first phase of the timeline begins with preparatory cargo missions. Starship will launch a series of uncrewed flights, carrying essential supplies, power generation systems like solar arrays, radiation shielding materials, and communication satellites. These early payloads will be the foundation. Think of them as the plumbing and wiring before the walls go up. They'll also include robotic units capable of assembling structures or preparing the lunar regolith for landing pads and construction zones. These robots will need to operate autonomously in extreme conditions, and the data they send back will guide every step that follows. Once basic infrastructure is in place, the next wave of Starship missions will focus on delivering modular habitats. These prefabricated structures will be designed for rapid deployment, unfolding or expanding like space-age tents. They'll include everything necessary to support human life: oxygen generation units, water recycling systems, climate control, and radiation protection. These habitats will likely be buried under lunar soil to shield occupants from cosmic rays and micrometeorites. It's a balance between high-tech and the raw resources of the moon itself. By this stage, astronauts will begin arriving in rotational crews. These initial human missions will focus on setup and troubleshooting, activating systems, conducting repairs, and establishing protocols for long-term operations. Starship's reusability is key here. It can bring equipment and people in one direction, and return samples and data back to Earth. It allows for a two-way exchange that keeps the lunar base supplied and informed. Throughout this process, SpaceX and its partners will face some of the most unforgiving challenges imaginable. The moon is no gentle host. Its surface swings between boiling and freezing temperatures. There's no breathable atmosphere and gravity is only 1/6 that of Earth. Worse still, the fine lunar dust clings to everything like static charged powder, capable of damaging electronics and clogging air filters. Every system must be overbuilt and redundant because failure on the moon doesn't mean inconvenience, it means catastrophe. One of the biggest breakthroughs necessary for a sustainable base is ISRU, in situ resource utilization. This means using what the moon already has to support life. Lunar regolith could be processed into building bricks. Ice deposits in permanently shadowed craters might be harvested for drinking water, oxygen, or even hydrogen fuel. If successful, ISRU transforms the moon from a barren outpost into a self-sustaining colony. Starship will play a central role in testing and deploying these technologies, carrying mining equipment, processing units, and scientific labs to examine the possibilities firsthand. The construction timeline will continue with the installation of long-term energy sources. Solar farms will likely dominate the early phases, but more ambitious projects like nuclear power stations are already in planning stages. Energy isn't just for lights and heat, it powers everything from water electrolysis units to oxygen scrubbers and pressurized labs. Without reliable energy, the base becomes a tomb. With it, the base becomes a city. Next comes the expansion phase. As systems stabilize and technologies prove reliable, Starship flights will increase in frequency. More habitats will be added. Laboratories for scientific research, hydroponic greenhouses for food, and even recreational modules will begin to form the skeleton of a small lunar village. This won't happen overnight. It may take years of steady missions, constant updates, and international support. But each successful step brings humanity closer to its first permanent off-world settlement. And through it all, Starship remains the heartbeat. Its massive payload bay becomes a lifeline to Earth. Its engines, refined with each flight, become the wings of interplanetary commerce. SpaceX's iterative design process, build fast, test faster, means Starship is constantly evolving. Every lunar mission teaches a lesson, and every lesson becomes a stepping stone. But the base is not an end point. It's a beginning. With a permanent presence on the Moon, the next phase will target the stars, most immediately Mars. Lessons learned from living off Earth for weeks, then months, will shape how we plan for years-long missions. Habitats tested on the Moon will become blueprints for Martian colonies. Resource extraction will evolve into closed-loop ecosystems. And Starship, already proven on the Moon, will stretch its wings further. This timeline isn't fantasy. It's under construction. Components are being built. Launch tests are being refined. The Artemis program, NASA's roadmap for returning to the Moon, has already selected Starship as the human landing system. SpaceX is not going it alone. The lunar base is an international effort, one that draws from the best minds in space science, engineering, and exploration across the globe. Still, challenges remain. Delays are inevitable. Setbacks will occur. But as history shows, ambition paired with relentless innovation can achieve the impossible. Just decades ago, the idea of reusing a rocket seemed absurd. Today it's routine. Building a city on the Moon may seem equally distant, but the first bricks are already on the manifest. And when the first permanent outpost stands firm on lunar soil, when the first sunrise is watched through reinforced glass, and the first seeds sprout in hydroponic trays under artificial lights, it won't be remembered as a miracle. It will be remembered as a milestone. A chapter in a new story, one written not just by SpaceX but by all of humanity. And at the center of that story, rising like a steel tower against the void, will be Starship. Because in the end, the Moon isn't the final destination. It's the launch pad for everything that comes next. The Moon base won't be built in a single mission or a single year. It will rise step by step, module by module, mission by mission, and each phase will demand unshakable precision and adaptability. In the earliest stages following initial landings, astronauts will begin establishing a semi-permanent outpost from the pre-delivered equipment. Habitats will be inflated, life support systems activated, and energy modules unfurled. These pioneers won't just be living on the Moon, they'll be testing its limits. Every hour will be a trial, every experiment a data point. The Moon will become a laboratory for surviving away from Earth. Meanwhile, Starship will continue its regular cadence of launches from Earth, delivering everything from pressure suits to drill rigs. SpaceX's fleet model, with multiple Starships operating in parallel, ensures redundancy and rapid deployment. Over time, lunar logistics will become more streamlined. Storage depots, landing pads, and cargo management systems will evolve to support higher traffic and reduce risk. Communication arrays on the surface and in orbit will ensure a constant data stream back to mission control on Earth. Then comes Construction 2.0, the transition from basic survival to long-term viability. This is when builders will shift from deploying prefab structures to constructing habitats with local materials. Robotic 3D printers might use lunar regolith as feedstock, printing walls directly on the surface. Radiation-hardened glass made from melted regolith could form protective domes. And ice from nearby craters might be converted into breathable air and rocket fuel. These advancements would drastically cut the dependency on Earth resupply, moving closer to full lunar autonomy. Safety will remain paramount throughout. Redundant life support systems, fire suppression tech, and automated medical diagnostics will all be tested and perfected in this harsh environment. Emergency protocols will be drilled constantly. Human lives will depend on both technology and training, and both must function flawlessly. At the same time, a wave of scientific exploration will unfold. Astronauts will venture into ancient lava tubes, study mineral deposits, and drill core samples that may hold clues about the early solar system. The Moon, long thought of as static and lifeless, will reveal secrets hidden for billions of years. Some missions will scout for ideal spots to expand the base. Others will focus on Earth sciences, using the Moon's position to monitor solar activity or distant galaxies with observatories free from Earth's atmospheric interference. Human adaptation will also be a crucial area of study. Extended stays on the moon will test the psychological resilience of astronauts and the effectiveness of support systems. Isolation, confinement, and altered circadian rhythms can wreak havoc on the mind and body. These lunar missions will help refine solutions, from VR therapy modules to biofeedback suits and personalized lighting systems. What we learn here will shape how we prepare for Mars and beyond. Education and outreach will play their role too. As live feeds stream from the moon base to classrooms on Earth, a new generation of scientists, engineers, and explorers will be inspired. For the first time, space won't just be something we observe. It will be something we build. That mental shift will be as critical as any technological breakthrough. Humanity will begin to think not just as inhabitants of Earth, but as citizens of the solar system. Commercial opportunities will inevitably follow. Once infrastructure reaches a certain threshold, private companies will see value in participating. Mining operations, fuel production, space tourism, and lunar manufacturing may become viable. The moon base could evolve from an international research station to a hub of commerce. Starship's immense capacity will enable frequent deliveries of specialized equipment, experiments, and even high-value exports back to Earth. By now, the moon base will resemble a village, not just functional but inhabitable. There will be routine schedules, designated work zones, greenhouses growing fresh food, and even leisure areas. The moon will still be dangerous but no longer alien. It will feel, at least in part, like home. At this stage, planning will begin in earnest for interplanetary missions. The moon base will serve as a launch rehearsal center for Mars. The gravity is low enough to serve as a fuel-efficient staging point, and systems tested on the moon can be refined before use in deeper space. Starship, equipped with lessons learned from lunar operations, will be retrofitted for longer journeys. Cargo modules will be adapted for Martian conditions, and habitat designs will be fine-tuned for the red planet. International collaboration will be vital in sustaining and expanding lunar presence. Countries from around the globe will contribute modules, research teams, and experiments. The moon base will become a patchwork of global effort, reflecting not only national pride but shared ambition. Each new addition, a laboratory, a habitat ring, a greenhouse, will be another thread in the fabric of humanity's future. Eventually, the moon base may transition into a governance model, with systems for managing resources, research output, and safety protocols across nations. New protocols for lunar law, emergency response, and environmental stewardship will be tested. The moon will evolve into a political and scientific testbed for peaceful cooperation in space. But let's not forget the emotional weight of it all. Imagine an astronaut standing in silence during a lunar sunrise, watching Earth slowly rise above the gray horizon. Imagine the first holiday celebrated with a live call from family back on Earth. Imagine the first child who grows up dreaming not of visiting space but of living there. These are not far-off fantasies. They are the natural consequences of what is already underway. The moon base will not be the end of the road but a crossroads. From it, humanity can turn outward to the planets or inward to protect our home world with space-based technologies. Earth observation satellites launched from the moon can enhance climate monitoring. Deep space probes launched from its surface can travel faster and farther than ever before. The Starship program, with its bold design and aggressive timelines, is our bridge to this future. Every landing, every payload, every upgrade brings us closer. The rocket itself is not the goal is what it enables. The moon base will stand as proof that we are no longer confined to one world. That we can dream bigger, reach farther, and build something extraordinary together. And when we look back years from now on the flickering footage of that first dome rising from the dust, the lights turning on one by one, and the Starship launching skyward from a moon it helped transform, we won't just remember it as a technical achievement. We'll remember it as the moment humanity became something more. We stopped being visitors in space, and we started becoming settlers.